All right. Hey, everyone. Welcome back to CSM. Today, we'll be talking about problem 3 on week 5's worksheet, which is on Java iterators. So, let's first talk about iteration. So, the goal with iteration, when we have a collection of data, is to basically do something with every element in that collection. So, in Python, we'd often write for element in collection like this. And then within that for statement, we'd do something with that element. In Java, we have something similar. We can use what's called an enhanced for loop. And much like Python, we can only iterate over certain types of objects. That is, the collection that we have here must be able to be iterated over. So what does iteration look like under the hood? When we write for my class element in collection, like in this enhanced for statement here, this is equivalent to all of this Java code right here. So what's going on here? Basically, if a collection is iterable, the collection is required to implement an iterator method. This iterator method returns an iterator, and an iterator has two methods, hasNext and next. So hasNext returns a Boolean that tells whether or not you're done iterating. If hasNext returns false, that means you've iterated iterated over all the elements within your collection, and you can end your enhanced for loop. If hasNext returns true, that means that we're not done iterating through our collection, and we can get the next element in our collection using iter.next. And after we get that element, we can do whatever we want with that element that we define within the body of this for loop here. So let's dive a little bit deeper into what exactly this iterator interface is. What must an iterator interface satisfy? What methods must it implement? If we take a look at iteration even more under the hood, we can see that our collection here must implement an iterator method if it wants to be part of the iterable interface. And then if we take a look at the iterator that our iterable returns, we see that the iterator implements two methods, hasNext, which returns true if iteration has more elements, and next, which returns the next element in the iteration. So just to summarize, collection here is of a type that implements the iterable interface. Both iterator and iterable are generic over the type of element, meaning that it doesn't matter what type of elements we're iterating over. We could iterate over integers, or we could iterate over custom classes. Having these generic types here give us all of that flexibility. And instances of implementations of iterator must keep track of where they are in the iterable with some set of fields. So you can only return the next element, and you can only figure out whether or not you have a next element if you keep track of some kind of state. So we'll see this in the example problems within the worksheet, but basically you don't want to accidentally not iterate over all of your elements in the collection, and you also don't want to iterate over any elements of the collection more than once. And classes in Java typically have some kind of custom implementation of iterator for themselves. So here's a little analogy to help you digest iterators and iterables. You can think of an iterable object as some kind of delivery route that the driver wants to take. And you can think of an iterator as an Amazon delivery truck. So the delivery truck can check whether they have another stop to deliver to, right? This is sort of equivalent to the hasNext method within an iterator. They can also deliver to the next stop. This is like the next method within an iterator. And you aren't just limited to a single iterator for each collection. A collection can have multiple instances of an iterator going through that collection. So there can be multiple delivery trucks on the same route, each independently driving through that route. So since iterable only has one method that just returns an iterator, it's actually a bit more interesting to think more about the implementation of a class rather that implements the iterator interface. So let's go ahead and see some examples. So this is the what list problem on week 5's worksheet. If we take a look here, we basically want to create an int-array iterator that implements the iterator interface that implements these has next and next methods. So if we take a look here, this int-array iterator is an iterator that iterates over the Java integer array. We can see that while our iterator has a next element, it'll go ahead and it will be valid rather for us to call iter.next to get the next element within that array. So now that we sort of understand what properties an iterator must satisfy, let's go ahead and think about the implementation. So if we take a look here, we see that, first of all, even though an iterator can be implemented for any generic type, here we're specifically interested in integers. So if we take a look at our class declaration here, our int array iterator must implement an iterator of generic type integer. The reason why we can't put int here is because in generics, we use reference types versus primitive types. Basically, Java will allow us to convert between integers here and ints automatically, but because generics only accept reference types, we can't put the int primitive within these angle brackets, right? So that's just one point to be careful about. We want the integer class here. And then we need to think about implementing our hasNext method and our next method. So in order for us to be able to implement, or rather traverse through the array, it'll probably be useful to keep track of the array that we pass in. So the first field that we can define for our int array iterator here would be a private int array. And so that we can use this array later, we can set our objects array equal to the array that we pass in when we construct our int array iterator. In addition, to ensure that we iterate through every single element within our array, and that we never iterate over any element more than once, it'll be useful to keep track of which index we've already iterated through. So we could have an int index here, and we can initialize our index to 0. So then how do we know whether or not we've iterated through our entire array? What we can do is check whether or not our index has reached the end of our array. So we can, in public Boolean hasNext, we can return index whether or not it's less than the length of our array. And then when we want to get the next element in our array, first, because we're implementing generic type integer, next should also return type integer. And the value that we want to return is located at the current index of our array. So we can have int value that we want to return be equal to the element at the current index in our array. We increment our index by 1 to indicate that we've iterated over this element in our array. And finally, we can return our value. So this would be the overall implementation of our int array iterator. One thing to keep in mind is even though this next method returns class integer, Java allows us to convert between primitive integer types and integer reference types. Next, we'll go ahead and do something similar, but instead of having next we'll go ahead and do something similar. This time, instead of having an array that we want to iterate over, we want to go ahead and iterate over an int list. So recall that an int list is made up of int nodes, and each node within a list has some element that it stores, as well as a pointer to the next node within the list. So again, our int list iterator must implement an iterator of generic type integer. Right. The reason why it's of generic type integer is because an iterator of an int node or an int list should return integers. Now, the first thing that we want to keep track of in order to be able to iterate over our entire int list is the current node that we're at in our list. So before we begin any iteration, the current node that our int list iterator is at is just the beginning of our list. To check whether or not we've completed our iteration, we can check whether or not our node is null. So if our node is null, that means that we've reached the end of our int list. And if our node is not null, that means that we can continue iterating through our int list. And then finally, if we take a look at our next method has to return an integer. The value that we return is the value located within our node. Then we need to move on to the next element within our list. So we'll set our node equal to node.next, or rather node.rest. And then finally, we return the value within our previous int node, like so. Finally, let's go ahead and think about how we can use the iterator that we've created to implement a print all method. So this is a method that prints every element in an iterator that outputs integers. So if we take a look at this method, right, since our iterator that we pass in outputs integers, our iterator must be of generic type integer. And given this iterator, we can take advantage of our hasNext and next methods to go through our entire collection and print out all of the integers within that iterator. So the way it looked like is while iter.hasNext, we'll go ahead and print out the next element within our iterator. So if we take a look at this implementation here, right, iter.hasNext checks whether or not we still have remaining elements within our iterator, and iter.next will go ahead and retrieve the next element within our iterator for us.